Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 4, and this problem asks us to draw the structures corresponding to each of these names. So, naming aromatic rings, specifically benzene, is a little different than naming straight chain alkanes, and I think actually it's kind of easier naming these benzene derivatives, because we know that, for example, the first one is isobutylbenzene. Well, right away we know that it's going to be a benzene ring. Benzene is a 6-membered ring with 3 pi bonds, all in some sort of hybrid form. So it doesn't actually matter if you draw it like this, or you draw it like, or if you draw it like this. And the reason is that because these two exist in some sort of hybrid, that these bonds are actually in between this carbon bond and these ones. So they all exist in some sort of resonance structure. So in essence, we can say that a benzene, in essence, is actually represented by a hybrid of these two, so it's just a dotted line all the way around. And some people can actually just draw the double bonds or the 3 pi bonds as just one circle in your benzene ring. So it doesn't matter how you draw your benzene ring, you can draw it any of these ways, but to be more clear, I would recommend drawing it either like this or like this. So now we have our benzene ring, and we know what isobutyl is. So butyl means 4 carbons. So we have 1, 2, 3, 4, but it's isobutyl. So you need to draw 3, 1, 2, 3, and the fourth one is coming out in the middle. So we can draw that. So we have 1, 2, 3, 1, 2, 3 carbons, and the fourth one is coming out in the middle. That's what the iso means. So we have 4 carbons, they're not in a straight chain, that would just be butyl, but it's an isobutyl, meaning the fourth one is coming out from the second carbon here. What about O-dichlorobenzene? So what does this O mean? So in a benzene ring, we have a few positions. So let's say that we have a substituent that's coming from the top here. So any substituent, we'll just call it any substituent. We'll just put a circle here, anything it is. Well, now the other carbons, these two carbons, and the carbon at the very opposite end, these 3 types of carbons are all different types of carbons. The ones in a red are directly 1 carbon away from this group in a red. The ones in a green are 2 carbons away, and the one in the black is 3 carbons away on either side. So obviously we have 3 types of carbons that are respective to this red group. So we can actually name these. So the red group is what we call, these 2 red carbons is what we call the ortho position. Or we can just say O. The green groups are we call the meta position, and we can call that by M. And this black carbon, the very sole carbon down here, is the para position. So we can call that P for para. So we have the ortho meta para position in respective to this red substituent. So what does it mean by O? So ortho dichlorobenzene. Well, we know right away it's going to be a benzene. So we know that's going to be a benzene. So and we have 2 chlorines. So I'll just arbitrarily draw a chlorine on the top, but now we have, it's dichloro. So where's the second chloro? Well, it's in the ortho position in respective to this first chlorine. So we know that it's ortho, meta, para. So the chlorine can either be on this side, or the second chlorine could be on the other ortho position, but these 2 positions are equivalent because of the free rotation. You could just turn it around and be the exact same structure. So the third one, we have a cis 1,2-diphenyl cyclohexane. So phenyl group is just another way of saying benzene. So phenyl and benzene are identical. So we have 2 benzenes at the 1 and 2 position on a cyclohexane parent chain. And not only that, now we have some stereochemistry that's specified. And these 2 phenyl groups, or these 2 benzenes, are cis to each other on the cyclohexane parent chain. So cis means that they're on the same side. Remember, trans is on the opposite, cis is on the same side. So our parent chain is a cyclohexane. So remember, cyclohexane, hexane means 6 carbons, cyclo means those 6 carbons are in a ring. And then we have 1,2 diphenyl. So at carbon 1 and 2, we have 2 benzene. So I can arbitrarily say this is carbon 1, and this is carbon 2, but now I'm drawing them as wedges to show that they're cis to each other. Then we're going to have 2 benzenes coming off of those. Or coming off of each group, I should say. Draw that better. That's 1 benzene. And that's 2 benzene. So we have 1,2 cis diphenyl or dibenzyl cyclohexane. Now what about M-bromoalanine? So M-bromoalanine, so we have M, so that means it's methyl meta position, sorry. Then bromo is on a meta position of our aniline. So what is an aniline? So aniline is just a benzene ring with an amino group on it. So it has an exocyclic amino group and an H2 group. So this is what aniline is. So the parent chain is our aniline, and now we have a bromo that is meta to this aniline, or this substituent, which is our amino group. So remember, ortho meta para. So we have 2 meta positions here and here. So we'll just arbitrarily choose one of them and put a bromine group on that. So we have M-bromoaniline. Now what about 4-chloro-1,2-diethylbenzene? So the parent chain is benzene. On carbon 1 and 2, we have 2 ethyls. And then on carbon 4, we have a chloro. So let's draw that. So we have a benzene ring. Arbitrarily, I'll choose this is carbon 1. So we have 1 ethyl, 2 ethyl, and 3 carbon 4. We have a chlorine group. So 1,2-diethyl, 4-chloro. And now what about this? 3-tert-butyl, 2-ethyl-toluene. So what is a toluene? So toluene is another derivative of benzene. So we'll draw our benzene. Toluene, instead of having that amino group like in aniline, toluene is just a benzene with a methyl group. So this is toluene. So now we have our toluene. Now on carbon 2 of our toluene, we have an ethyl. So this is carbon 1. So on carbon 2, it can either go from the right or the left. Carbon 2, we have an ethyl. And then on carbon 3, we have a tert-butyl group. So tert-butyl is just your cross. 4 carbons represented in a tert shape, or a T shape, or a cross shape.